Hello, everyone, and welcome to our 10-year anniversary series. In this series, as you know, we have people from all backgrounds that are part of the HP Systems community, and we are just trying to bring a little bit of a historic perspective on what they have been doing and how they joined the community, and certainly what things are coming down the road. I know that 10 years is a very long time, but we hope to have another 10 or 20 years more here. So for this particular occasion, we have two great exponents of our HP Systems community. And those two people, of course, you probably know them because they participated in many other events before, are Lili Xu, and Yash Mishra. Lili and Yash have been involved with HP Systems for a fairly long time now. They've been part of the community coming from our academic program. So we met them as we were doing some of our academic activities, and they just became part of the community and advocates for HPC systems. So with this, hello, Lili. Hello, Yash.
Hello, Flavio. Thank you for
Welcome.
inviting me.
So let's get started there. So then, Lili, can you tell me how you got into HPC systems? So how did you even know about it?
Sure, I think that's really starting from since I'm academia, projects, commerce. So definitely my background is from my academia. So my first year, PhD year, I was in the Dr. Amy's DICE lab. And then she was like, "Oh, do you want to learn something about big data?" I was like, "Yeah, sure. Why not? So it's really hot now." Okay, then I have a thick book here, and then do you want to take a look? I was like, "Okay." Okay, it's ECL Programmer Guide. I was like, "Okay, that sounds interesting. So what is ECL?" So from there, I learned about HPCC systems, how it's a underlying distributed high performance cluster works, and how ECL as a programming frame work on top of HPCC help us to um, apply different methods on big data and then working flexibly in HPCC systems. So from then on, like even now, it's been like 5 years, I think, 6 years. I've been always working with HPCC systems and from different aspects, from machine learning to even purely ETL and academia collaboration, hackathons. Yeah, it just all started from then on. Yeah,
I know, and 5, 6 years, I know, and time really flies.
I know.
So, and yes, how about you? How did you get into this?
Oh, okay, following Lily's footsteps. In my very first semester, I was in Dr. Amy Apon's cloud computing architecture class. And so halfway through the semester, Dr. Apon introduced us to HPCC systems as a part of a midterm project that graduate students could do. And so that looked very interesting. And so we were studying about cloud and how distributed framework works. And then Dr. Apon introduces us to HPCC systems and how we can think about ideas and running that on the cloud. And so that's where it came in. And then studying about the different components like Thor and Roxy and how the servers work, and going into like mapping with some of the cloud services that we can deploy that on, and moving forward towards the subsequent semesters. I was in Dr. Apon's DICE lab, and mainly working with HPCC related projects with the cloud aspects. And then coming this past summer, I was fortunate to get an internship with HPCC Systems, leveraging the Azure Cloud Platform, and so that got me glued to like distributed framework and to the community, and that's how like my journey began, and it has been splendid so far.
That is very good. Good to hear. So, but I know that, and I remember, Lily, you've done a number of also research projects around HPCC systems and ECL as well. So, what was the core topic that you have been researching, and what's the? I know that you published a number of papers. So, can you tell us a little bit more about that?
Sure, I love to. So I have done so many works, but I think mainly focus on the clustering methods, on distributed clustering environment, and HPCC Systems is the perfect platform for me to apply my research on top of it. And then I did my K-means, parallel scalable K-means on HPCC, and we have a paper on that. I published on Big Data IEEE conference, and we have Young K-means. It's also a clustering methods. It's based on top of K-means, but it's more out or computation saver for K-means because we have so many distance-based computation on K-means. It's very inefficient. Young K-means using some triangle theory to reduce the computation in that aspects. And then we have a job. When I came into a company, I joined a company officially, and we did a lot of internships. I'm as a mentor. I mentor some supervised machine learning, and for clustering aspects, we do some natural language processing projects. For example, last year we have a project to applying such as text vectors bundle to analyzing to financial SEC data. Based on that, we're clustering the results, see how many financial filings have similar features or failing results. So those are the clustering methods I basically worked on in the last few years. And then, oh yeah, and one more is for DBSCAN. So DBSCAN is another
Yes,
clustering
yes, I
method.
remember
Yes,
that. Yes, absolutely.
yeah. And that one is pretty awesome because we know K-means or Eon K-means, they all based on the um, classic distance-based classroom space, but DBSCAN is a density-based space, so it's more flexible and more like smarter. It can automatically decide the number of clusters and on and on. So many good stuff. So I implemented
You're right. Yeah, I
DBSCAN.
remember now. This kind doesn't require the hyperparameter on defining the number of centroids that you want, right?
Right. Yep.
So,
Yep. So we did that to improve the current clustering methods we have in HPC systems machine learning library. So now we have K-means, we have a DBSCAN or available for all the HPCC users who using these clustering methods on their own machine learning projects. Yep. And
so
that's pretty much what I did.
yeah, that's
Yeah.
a great story, and also you mentioned all of the mentoring. So Yash, on your side, you have also been doing some research, right? So what have you been doing?
Well, sure. In uh, like uh, working with like prior to my internship with HPCC Systems, was working with Dr. Apon on like researching different ways HPCC systems can be deployed into the cloud. And so the idea was like everything being moved to the cloud, like the push that is coming to the cloud, how would you deploy a distributed like architecture on the cloud with the tools that are available? And so like researching about how how the cloud operates, and then uh, an application such as HPCC systems with its different components, and uh, trying to find out uh, how the different like compute network and storage stack is handled in a legacy version versus how that is handled in a cloud version. And now even with the cloud, you have a lift and shift versus you have a more like re-architecting containerized approach using containers and Kubernetes. So how would like one version on the Kubernetes is different than the legacy version. And so that has been like interesting to compare the architectural and qualitative trade-offs. And
Well, and
yeah.
sorry to interrupt, but that's quite important also for our 8.0 version, because we are going to have more extensive support of cloud environments, and knowing how that can impact performance or runtime, I think it's quite critical, right?
Right, absolutely. Yeah. And so uh, uh, yeah, getting like you mentioned about the performance differences, uh, kind of being involved in that to see how the platform itself runs on two different environments is something that I've been doing. And yeah, that is something which uh, would help like researchers and even developers identify what are some of the costs associated, since every different type of resources on cloud being a pay-as-you-go model, you hire somebody else's computing platform to deploy your system. And so identifying some of the the costs also is like something that I've been doing.
Very good, very good. And what's coming down the road? So what are you working on nowadays? And I don't know, Lili or Yash.
Yep, I can go first. Yep.
Sounds good.
Um,
Yes.
yeah, so I did a lot about machine learning stuff, and then someone may say, "Okay, I'm come out from ECL circle. I'm not sure about what is ECL and how is a distributed computer environment works." I'm saying, "Oh, no worry, we have to do something for that for you." So we have HSQL. That is my latest project. So
Oh, that's a
if you know
great piece. Yes,
SQL,
HSQL,
yeah.
absolutely. Yes.
You know SQL, then you are fine. You are totally fine. You can using that. Basically, SQL-like syntax is called HSQL, and then the user can just using the SQL-like syntax working in HPCC. No worry about underlying complex of how HPCC works. Just compile your code, and then it's gonna be automatically working in HPCC systems. And also, and one more aspect is I think we all know ECL is really strong tool or programming framework for ETL jobs. And those are the main reason why that we have ECL basically instead of SQL. But now we turn back. Once ETL finished, then what we do is we do analytics, we do visualization. But from our observations that maybe sometimes ETL is a lot more, maybe some coding tasks that maybe data scientists or modelers they don't want to deal with. So maybe HSQL somehow is more simple, the simpler version of the works you can down using SQL like syntax instead of using ECL. Yep.
I,
So
I,
I'm really excited working on this.
I must admit that I haven't looked much into HSQL yet, but I look forward to your presentation this Friday, Lily.
Oh
Yes,
yeah,
yeah, that's
sure.
going to be really good. Now you made me want to learn
Excited
more
about
about it.
more.
Yes,
Yeah,
yeah,
that's
absolutely.
good.
So you said that this is mostly oriented towards querying, right? Query visualization and data access for the most part, more than data transformation.
For HSQL, actually, it's more than that. We have basically query functionalities, like basically standard SQL query functions. We also have a visualization, plotting functions for you to easily, like a BI kind of task, to reporting your data in different format, like pie charts, bar charts, like that. We also have an easy creation function for machine learning models,
Oh,
and
that's
that's
very
the
cool. Oh,
yeah,
I like
that's the
that.
best part. So you don't have to really learn what is annual core bundle, what is a to fill function. So someone say how I
Oh,
transfer
wow.
data into the perfect format, and now just like two keywords train. The train keywords and from define your data to train the model, then that boom is done. So,
That is
yeah,
very good. That sounds like magic, though. So we'll see.
yeah, it makes it really simpler than it used to be in sales. I think it's really helpful for data scientists or modeler who don't want to deal with
Cool.
the complex ECL coding parts. Yep. And
That-
definitely good for those who don't know ECL at all. He only know like say I only know SQL. So then that's definitely the best choice using HSQL instead.
Very good. Very good. Yeah, that's great. So and Yash, so how about you? What are you doing nowadays?
Well, so me, I joined the company just last week on March 1st,
Welcome.
and yeah, I've been trying to learn my new project, and so I'm in the motor vehicle records MVR team, and yeah, I've been working on understanding the product, uh, and then trying to assess how like the different Roxy subsystems and then the Thor batch processing is operated, and so like getting my feet wet with that,
So,
and
sorry,
pretty soon
just for
getting
the
up.
record,
Yeah.
both Lily and Yash both are now LexisNexis Risk Solutions employees. So Lily has been an employee
Yes.
for a very long time, well, many years, but Yash has joined, so that's I think that's just to give context to everyone. So and
Yeah.
what else? So what do you think Yash is going to be? What you will be doing in the MVR area in motor vehicle records?
So I'll be helping I'll be working in the image squad, and so helping stakeholders and product owners and the team with HPCC and ECL development aspects of MVR, and uh, uh, working as a software engineer to design
Mhm.
new features uh, uh, or provide it for testing, and of course debugging some of the challenges. And apart from that, I'll also be invested in some of the impact analysis in case there is a production or big issues. In trying to get my hands wet in the new project as well. Yeah.
That is very cool. And of course, your background also in distributed systems and all of the work that you have done will help also perhaps optimization problems and other things that might need your help as well. That's very good. So, folks, I don't want to make this too long for the audience. I think we already exhausted pretty much our quota for today. But this has been great. It is great to see how the academic program eventually gets people that are really valuable in the community, of course, and also in the company as well. So, because
Yep.
both of you have joined the company eventually, that's very good.
Yep. And thank you so much for making the academia projects are so successful. And we all been from intern and then now finally become the employee for HPCC Systems. So we really feel appreciated. Yep.
That is
Yeah.
great, and 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 again, this is all part of what the community is about. So this is great to
Yep.
see people, great people join the organization as well. LexisNexis Risk Solutions, but also being active part of the community for so many years. So that's just the tribute to the community itself. So
Yep.
thank you very much,
Sure.
folks, and this has been great. And I look forward to the HSQL presentation on
Oh
Friday.
yeah, sure.
Yeah. Is it live?
It is. It's going to be live. Yes.
Yep.
Okay.
Thank you very
All right.
much. Thank you, folks. Thank you.
Thank you and a
See you.
happy HPCC 10 years open source.
Oh,
Very good. Yeah, absolutely. Happy 10 years
Yes.
anniversary
happy
for
then.
the open source community. Yes.
Yep.
Thank you.
All right.
Thank you,
Thank
folks.
you. All right. Bye.
Thank you.